Today's lesson 7.2 is about writing and graphing equations in the form y equals mx plus b. So in this first example, we're just going to be graphing linear relationships. Our example says, Teresa signs up for a membership to rent video games. The company charges $5 per month and $2 per video game. Graph a linear relationship between the number of games Teresa rents and her monthly cost. So in step one, we're going to start by making a table. We're going to be recording different values. There should be an S right there for the linear relationship. So this table, of course, already here for you, says that if we rent 0 video games, since you have a monthly membership, it's still going to be $5 plus $2 for every video game you rent. Well, since we didn't rent any, you know that 2 times 0 is 0, and 0 plus 5 would give us a $5 cost. If Teresa rents 1 video game, remember we have to multiply before we add, so 2 times 1 is 2, 2 plus 5 would give us $7. If we rent 2 video games, 2 times 2 would be 4, and 4 plus 5 would cost us $9. If we rent 3 video games, 2 times 3 is 6, and 6 plus 5 would cost $11. And if we rent 4 video games, 2 times 4 is $8, plus 5 would be $13. So this column, the number of video games rented, this is our X value. Okay, our X value is our input. I want you guys to write this down in your table. Okay, and this column, our cost, is our Y. This is our output. So the Y is like our answer. This is what we're looking for. We're looking for the cost when we rent the number of video games. That is our X. So remember that on our graph, the X is our independent value and the Y is the dependent. So if we graph, remember you go down the hall, then up the elevator. So if we are at 0 on the X, then we don't go down the hall at all. We stay right on the 0. Go up the elevator to 5. You're going to plot a point there. If I go down to 1 on my X, up my Y value is going to be 7. So it's going to be right below there. And when I rent 2 video games, it's at 9, so it's going to be right below that 10 mark. And when I rent 3 video games, it's at 11, so it's right above the little mark there. And then when I rent 4, it's at 13, which would be above that halfway mark. So notice that a linear relationship, these dots are in a straight line. In the reflection, okay, we used our, well, before we get to the reflection, we used our X and our Y value as ordered pairs. Okay, so we used our table, and these ordered pairs are coming from the values in our table. That's our X, that's our Y. So notice the first ordered pair is 0, 5. In an ordered pair, remember X always comes first. Your Y value always comes second. And that's why I always say go down the hall, up the elevator, down the hall on the X, up the elevator on the Y, down the hall on the X, up the elevator on the Y. So always graph your X value first and then your Y coordinate second. After you graph, you notice that, again, these dots are in a straight line. Well, the reflection is asking, do the values between points make sense in this context? So basically it's asking you, does it make sense to connect the dots, to connect the values between our points that were given? And really, think about the question, we're renting video games. So can you rent a part of a video game? No. So you're going to say, no, you can't rent part of a video game. So we can only use whole numbers. And I'm running out of space, so I'm just going to abbreviate that number sign. Okay? In the next section, we're talking about writing linear relationships. It says you can write an equation to describe a linear relationship. The equation of a linear relationship is y equals mx plus b, where m is the rate of change. Okay, we talked about that in the last video. And b is the value of y when x is 0. In our example, it says Anthony runs a bicycle courier company that charges $3 per delivery plus 50 cents per mile. Write an equation to describe the linear relationship. So before we write our equation, our first step would be to make a table. So again, if we go 0 distance in miles, this is our x value. We're trying to figure out the cost for the delivery. So it's going to charge, the company charges $3 plus 50 cents, that's where the 0.5 comes in, times the number of miles. Well, if we go 0 miles, we know that when we multiply 0.5 times 0, we get 0. So 3 plus 0 in the box we would put, that would give us a cost of $3. If we go 1 mile, 0.5 times 1 would be 0.5, and 3 times 0.5 would give us 3.5. If we have to deliver 2 miles, it's going to be 0.5 times 2, which would be 1 whole, so 3 plus 1 would give us a $4 cost. If we go 3 miles, 0.5 times 3 would be 1.5, so 1.5 plus the $3 charge would be $4.50. And if I multiply 0.5 times 4 miles, that would be 2. So 3 plus 2 would give us a $5 cost. Step 2 is to write an equation for the delivery cost y for x miles traveled. When the distance is 0, the cost is, well, we saw that when the distance was 0 in our table, our cost was $3. Okay, with each additional mile, how much did my cost increase each time? Well, our problem told us that for each mile, it was going to increase by 50 cents. So we're thinking about exactly what the problem means in words before we put it into an equation. So when you look at your cost, okay, our cost is what we're trying to figure out. Okay, remember that y is like your answer. That's your output. That's what you're trying to find. So our cost, we're going to use y to represent our cost. Well, 50 cents is already a number. Times means we're going to multiply the 50 cents times the number of miles. Well, the number of miles, notice that it changed every time. Okay, it varies. Well, what do we use when something varies? We use an x, or a variable. Okay, plus means we're going to add that $3 charge. Okay, so now I can write my equation. I'm going to have y equals 0.5 x plus 3. Now, notice that I dropped the multiplication sign. Okay, we could have used a dot here as well to represent our multiplication. But remember when you put a number next to a variable, it also means to multiply. So you don't need the multiplication sign. So here I'm saying that it's 0.5 times the number of miles plus $3 will give me y, my cost. So you're going to be writing equations from a given problem. On the back of your notes, you're going to read these two problems and try to write your own equation to describe the linear relationship. So pause your video All right. In the first example, in the first year turn, number 2, it says that the temperature of a pot of water is 45 degrees Fahrenheit. The temperature increases by 20 degrees per minute when being heated. Okay, so your equation here should have been y equals 20x plus 45. Okay, remember that 20 is our m, and m was our rate of change. Okay, so it's changing by increasing 20 degrees per minute. So the x represents our minutes, okay, our variable, because that's going to change for every minute. It's going to increase by 20 degrees. Plus 45 is the temperature it was already at before it started increasing every minute. On the second one, number 3, it says a bamboo reed is planted. It is 12 centimeters tall, or when it is 12 centimeters tall, it grows 2.2 centimeters per week. So here your equation should be y equals 2.2 x plus 12. Okay, so y, remember that's our answer, that's what we're looking for, equals the 2.2 is our rate of change because it is growing 2.2 centimeters per week. So per week means that however many weeks that it's growing, you're going to multiply it times the 2.2. Plus, it was already 12 centimeters when we planted it. So that's why it is plus 12 here. Okay, so now that we have looked at graphing a linear relationship and writing an equation, we're going to look at representing linear relationships using multiple representations. In example 2, it says, Charlie starts with $350 in his savings account. He withdraws $15 per week from his account. Represent the relationship using a table, an equation, and a graph. Step 1, of course, is to make a table. Well, remember that when we made a table on the front of our notes, okay, that table represents a linear relationship because it's like the pattern you find is when one value is increasing by a constant rate, you find that your other value is also increasing by a constant rate. Okay, when we were graphing, you notice that your dots were in a straight line, so the graph is modeling a linear relationship by those points forming a straight line. And then you were writing an equation, okay, and the equation that models a linear relationship will always have to be in the form y equals mx plus b. If it cannot be written in this form, then it's not going to be a linear relationship. So here they want us to look at all three. So we're going to start by making a table. And if Charlie starts with $350 in his savings account and he withdraws $15 per week, well, in the first, remember this is our x, this is our y. In the first row, it says that he withdraws for 0 weeks. Okay, so 15 times 0, is 0. So 350 minus 0 is still going to give us 350. Here, 15 times 1 is 15, and 350 minus $15 would give us $335. Here, 15 times 2 is 30, so 350 minus 30 would be $320. Here, 15 times 3 would be 45, and 350 minus 45 would be $305. And here, 15 times 4 would be 60. 350 minus $60 would be $290. So now that we have our table, the second step, they want us to go to writing an equation before we graph. So in writing the equation, this one's a little bit different. So you really need to think about the words before you actually go put your equation in the box. So if you think about this problem, it says that Charlie started with $350 in his savings account, but every time he's withdrawing money, notice that we weren't subtracting in the table. What were we doing? I mean, we weren't adding like we were before. This time we're subtracting. So 350 minus $15 times the number of weeks. I'm going to have to abbreviate because I'm running into my box. So if you think about what you're doing here, it's easier to write an equation. Well, you know that your y is your answer, okay? Your y is your output. And this time, it's going to be 350 minus $15 times the number of weeks. Now, we talked about the equation being y equals mx plus b. And here, notice that the mx is, it's just on the opposite side. So remember that adding, or I should say subtracting, is the same thing as adding the opposite. Okay, we learned that when we were adding and subtracting integers. So if I were to write y equals negative 15 times x plus 350, really I would get the same thing, because negative 15 is because when you withdraw money, you're taking it out. So that's why it would be negative 15. So however many weeks you do that, when you multiply this and you get a negative answer, remember when you have a negative and a positive, you can't add them. So what do? You end up subtracting. So really, even though our equation is written differently, it's the same thing. Okay, so now step 3, they want us to use our table values to come up with our ordered pair. Well, again, remember your ordered pair is x is always first, and then y. On the other side of your notes, it listed the ordered pairs for you, but now we're going to be listing the ordered pairs on our own. So you're going to have to look at your x value, 0, and your y value, which ended up being 350. So our first ordered pair would be 0, 350. Our second ordered pair would be 1, 335. 1, 335. Our next one would be 2, 320. Our next one would be 3, 305. And our last one would be 4, 290. Okay, well, now that we have our ordered pairs from our table, well, now they want us to go plot them on the graph. And notice that the dots are already there for you, but we're going to go ahead and go through this. At 0, we just go up to 350. I want you to go ahead and darken that dot that's there. At 1, we go to 335. Go ahead and darken that dot there. At 2, we go to 320. At 3, we go to 305. And at 4, we go to 290. Well, notice that his savings account started at 350, but as he took money out, what's happening to our line? It's going down, okay, instead of going up like you saw in the other graphs. In the reflection, it's asking, does it make sense to connect the points on the graph with a line? Explain. So again, if I were to connect these dots with a straight line, do the points in between the given points make sense? And here you would say no, because he's withdrawing $15 every week. So the points in between wouldn't make sense. Okay, so we're going to go ahead and write that. I want you to say no, comma. We'll say Charlie withdraws $15 a week, So there are no values in between. Okay, in the your turn, you're going to be reading this problem, and you're going to go through all of the steps. You're going to make a table. Okay, they want you to also write an equation, okay, just like we did here. And they also want you to put it in the graph. So I want you to pause your video and try what you learned on your own. Pause your video. Okay, let's see how you did here. Your turn says, a bicycle rental company charges $18 to rent a bike plus $7 for every 2 hours of rental time. Represent the relationship using a table, an equation, and a graph. Okay, so it's $18 plus $7 for every 2 hours. Well, in the first row, that was 0 hours. So you know that 7 times 0 is 0. So 0 plus 18, this value is still going to be 18. Okay? For 2 hours, well, it's $18 plus, it's actually going to be a 1 here because it's for every 2 hours. Well, how many groups of 2 hours are into only one group? So 18 plus 7 would equal 25. So you really had to pay attention to that here for the every 2 hours. So how many groups of 2 are in 4? 2. So here it's going to be 18 plus 7 times 2. So really it's 18 plus 14. You should have gotten $32 here. For 6 hours, how many groups of 2 are in 6 hours? Well, 3. So 7 times 3 is 21. You should have added 18 to 21, and you should have gotten 39 here. And how many groups of 2 are in 8 hours? Well, 4. So 7 times 4 is 28. You should have added 18 to 28, and here you should have $46. Okay, well, now that you have your values, you can use your ordered pairs. Again, this is your X, this is your Y. And we're going to write our ordered pairs over here. We have 0, 18. We have 2, 25. We have 4, 32. We have 6, 39. And we have 8, 46. So that's what we're going to be plotting over here. On our 0, 18 is going to be just like right below that 20. And then we have at 2, we have 25, which is going to be like right in the middle, because if it's counting by 20s, then obviously that's 30, so that would be right in the middle of those two. At 4, we're right at 32. At 6, we are at 39. At 8, we're at 46. And yeah, that was the last one. Okay, so they should make a straight line. And when you are writing your equation, because it was times 2 hours to be $7, but in your equation y equals mx plus b, remember this is your rate of change. This is per hour here. So if 2 hours cost $7, then this would be, well, then how much is it for 1 hour? Well, you would cut that $7 in half, and so your equation should have been y equals 3.5 times x plus the $18 fee that charged to rent the bike. Okay, so this is what we're going to be working on for the next couple of days. If you have any questions, you can ask us tomorrow, and I probably won't see you guys till after Christmas. So have a Merry Christmas.